Okay, I suggest we start because we have a full schedule. Thank you all for being present. I hope this will be interesting for you. Last week before the Easter holidays, just a few rules. We will be recording the workshop, so it is available offline. We'll also take care of any privacy concerns, especially as it is a security workshop and industrial IT, so we'll take care of that. The slides will also be available after the workshop. And if you have any questions, please raise them, challenges. I promise Cedric that there will be no awkward silences, so please do not let me down. This workshop is set up by 3 partners, so research from Sirris, technical experience from Enviso, and industrial applicability from HMS. We've been working for quite a while on the idea since last year, and we were hoping that we will have a more face-to-face experience so we can talk about it, we can discuss it openly, as this is an important topic to discuss, but things happen. But we decided it's way too critical to postpone, so hence this virtual event. But please, the floor is also open to raise your questions. We'll have 3 big blocks of sessions. And after each block, you can ask your questions, and at the end, you also can ask questions. Of course, you can contact us offline. So raise your hand, or you can also put it in the chat during the presentations, and we'll take care of it. Okay, so we will have a first setting of the stage by Sirris, which will be more focusing on highlighting popular attacks and some specific statistics. Of course, the idea of such workshops is to scare you, and then we'll provide you some solutions from Enviso on security challenges, how to connecting your machines to the cloud, and lessons learned on securing their products from HMS. So the first session from Sirris. Who am I? My name is Anna Christoskova. Maybe I should have started with this, but you all seen my name. I work for the software engineering group of Sirris, and my interest is specifically on secure and distributed AI. And maybe I can ask my colleague Amanda to present himself.
Hello, everyone. My name is Anand Rarat. Actually, I'm from the same team, same group with Anna. So I'm working for Sirris quite a while, and my area expertise in data and system securities, especially in asset control of asset and user control of data. We are working also for a while for the security in IoT ecosystem.
Okay, thank you, Ananda. The first part will be presented by my colleague Ananda, who is software security expert at Sirris, and he will focus on industrial security threats landscape and lessons learned. Ananda, the floor is yours.
Thank you, Anna. Do you see my screen now?
Yes.
Yes, okay. Okay, for this part of the workshop, we highlight the security landscapes in the industry Internet of Things. So there's no doubt that the Internet of Things influenced the world in the same manner as the World Wide Web and Internet did in the early 80s. IoT makes the world more connected and open more business opportunities. However, it brings a lot of good things. There are so many challenges that we are facing, such as security threats. A connected world makes us more exposed and also vulnerable to attacks. According to the report by Gartner's, by 2025, over 25% of all cybersecurity attacks against business will be IoT based. This raises alarm for the company working in these sectors. For machine builders and factories, IoTs allow them to transform their business, their traditional business, to the Industry 4.0, entering the smart, connected world of IoTs. Smart and connected world also offer new business model like digital civilization that are. Yes.
I'm sorry, but we don't see your slides.
Sorry.
We only see the first slide.
It's now it's working.
No.
Why?
Unless it's only me.
How about other?
Indeed, we can only see the first slide and it doesn't move.
Perhaps try to reshare your content.
Yeah. Wait, I will share. Yes, strange then. Can you see it now?
No. Now you will see moving, yeah.
Okay, I think maybe it's the problem. Moving, right?
Yes.
Yes, that's good. Okay. So, sorry, technical problems. So, I started this because IoT also offers a lot of good things to industries, such as the machine builder and factories. IoT allow them to transform their traditional business to Industry 4.0, entering the smart and connected world. IoT also offers new business model like digital digitization and data-driven business. It also help improving the operational efficiency in different domains such as predictive maintenance, sustainable production, and so on. In combination with advanced IoT technology and the advanced communication technologies such as 5G and NB-IoT, also with the advanced data analytic method like artificial intelligence and machine learning, that's also bring even more opportunity to the factory and machine builders. IoT, as I already said, that it bring a lot of good things, increase productivity, improve business decision. However, it also have a security concern, or we are also facing many security challenge. We connect it, make it open. It's more open than before, and then it of course increase of the attack surface is also a security concern. Since attacker can have more way to get into the system. There also are any other security problem because most of the system they use the legacy and the software and hardware that was not designed for IoT infrastructures. Another concern related to the regulation that control how the data should be shared, especially when we deal with private data. There are several security concerns concerning the IIoT, such as the cyber terrorism, where the attacker try to get into the system, steal the data, and so on. IP linkage, production sabotage, operation disruption, business disruption, of course, is also the big concern in IoT environments. Data breach also one of the concern because some company they are working with private data and need to be protected. Need to be protected correctly in order to be complied with regulation like GDPR. And finally, human safety also concern. While when we want to adapt the IoT system, we need to consider different security aspects, such as infrastructure, how to secure it, system management, how to manage it securely, how to protect data securely, and finally, if we work with IoT products, then we need to look at how we design the product securely and also how to deploy it and operate it securely. If you look at the attacks on IoT sectors, we see that there's a lot of attacks. According to report by Ford in 2019 alone, there are around 2.9 billion attacks on IT device. That's a lot. However, there are several populous attacks that reach the press. I listed here several. Of course, there are a lot of more than that, but we select a few attacks to raise awareness about the attacks, cyber attacks cases in IoT industry. The first one is the Mirai attacks happened in 2016, where attacker tried to exploit the weakness of the IoT device in the internet and then use it as the base to launch the denial of the severe attacks on a selected target. And also another attack that happened in 2015 that attacked the zip car, that the hacker tried to exploit the weakness, the security flaw in the firmware updates in the car, and attacker was able to take control of the car completely and then send the car off the tracks. Another attacks in 2020 on the Tesla model. This one is ethical attack performed by a researcher group in COSIC group in KU Leuven, where he tried to steal the car by attacking the key, the fob key, the key that used to identify to get in the car. And the researcher was able to rewrite completely the firmware in the key, and then was able to steal the car just within 3 minutes. Another example of attacks on the IT device, like Philip Hu's smart bull attacks, and also the gadgets attack, the attack on the gadget device happened in 2017 in US. The device that developed by St. George Hospital, and the attacker was able to get into the device and redirect the data, the heart data of the patient to themselves instead of sending to the doctors. And this attack forced the hospital to recall around 500,000 devices back to the factory. If you look at the security in IoT environments, we see that there's a lot of security, but we list here only the top 10 that's likely to happen. And we divide into 3 main categories: the IoT device levels, network and system level, and data level. If you look at the IoT level, the most common is the use of insecure or outdated components, the lack of device management, including the device onboarding to the system, the insecure default setting, like using the default password, factory and default password, and finally, the lack of physical hardening. This means that the protection of the device itself. If you look at the attacks example of physical hardening, you can consider this is also one of the popular attacks in Xiaomi cleaning robots, where attackers try to use the aluminum foil to short circuit some of the tiny contact between the motherboard and the processor. And doing so, they be able to force processor to enter special mode, allowing reading and writing to the flash directly to USB. It's important to note that attacker try to play around to try to hack the system using different ways, like looking to system, looking to the port, and but they could not find it, but could not find a way to hack the robot. But using this simple aluminum foil, they can actually finally hack the robot successfully. If you look at the network insecurities, the most common threats are the weak passwords, the bad habit of using weak password in the system, insecure network service, insecure ecosystem, and also protocol, including interface they use, and the lack of the device, the system update, including the firmware update, and so on. And also this also common threat to the IoT environment in the network and system level. If you look at the attacks, the popular attack related to this part, we see that the water treatment, the attack on the Florida water treatment plant in last 2 months, in February 2020, where attacker tried to get into the water treatment system and try to poison the water supply. So the attacker was able to get into the system by exploiting the weakness in the secure protection of the old software, and also the poor password habits. They also popular attack to the smart buildings. The attack to the smart doors of the Nortec security control, where attacker try to get in, was able to get into the smart doors, and then they launch a denial of service attacks. These attacks affect around 2,300 buildings, including corporate headquarters, factory, and industry parks. Another attack related to the Philips Hue smart bulb that happened in 2016 and 2020, where attacker used a drone to fly over the house and the building area, and then they was able to hack the smart bulb, and then they set the virus-like reaction to the smart bulb, and some these vulnerabilities are still not yet fixed. Concerning data, there's two common threads. The first one is insecure protection of private, privacy protection of the data generated from the IoT device, and the insecure data sharing and storage. A good example of insufficient privacy protection is the attack on the TriNet webcams, where the attacker explored the attacker webcams through the faulty software and was able to get the IP address. With the IP address, it let anyone to look or listen to the camera. Then interesting is that the company markets this webcam as a secure view camera for several uses, for various uses. There also, if we talk about the supply chain vulnerabilities, there is also the measures to IoT securities. This is because normally there's no control over the upstream supply chain component for IoT infrastructures. IoT infrastructure can use different IoT device products from different companies, and there's no control on that. And also, if one of the devices, have security flaw, it can jeopardize the entire system. Also, there lack of traceability of the origin of the elements using in the IoT in infrastructures. If you look at the attacks in Belgium context, according to report from a specialized company called Scopes, he found that Belgium is one of the biggest cyber attack targets in the world. It found that 49% of company experience more or less or fall into the victim of cyber attacks, compared to only 39 the global average. It also find that the company in Belgium seem to underestimate the risk of cyber attacks, and only 3 out of 10 companies have the incident coverage in case of cyber attacks. I just take a good example. I think we can also hear cyber attacks in Belgium is two popular cyber attacks. Is Picano group that happened last year, January last year, that forced the group to shut down the operation for 7 days, but they recover well. But not the same case in ASCO, the company that's built the aircraft part for Airbus and Lockheed Martin. They also experienced cyber attack, but they spend months and still not really fully recover from the attacks. If you look at the number of attacks, perspective of number of attacks, cyber attacks in IoT device globally, according to the Ford report, in 2020s, there's around 20,000 attacks every 15 minutes. And if we compare to 2019, there's 300% surge in the number of attacks. And in 2019 alone, there are 2.9 billion attacks on IT device. That's so that is really, really concern. Security is very important, and it's so that there's a big concern in the security of IT infrastructures. The report by Nokia in 2020, they monitored 15 million IoT devices, and they found that 20% of them infected or have been a target or have been hacked. And if you compare to this 2019, it's only 16%. This means that there's 14% rise in 2020. If you look at the markets, the market share for the IT product or IT sectors, and also the number of connected devices, we find that the number of the markets become growing in significantly. They predict that by 2025 there will be $1.6 trillion market share for the IT sectors. And if we look at the number of connected devices, it will increase from 21.5 billion connected devices in 2020 to 3.9 billion devices in 2025. This, we see the number of device used and also increase, the market growth also increase. At the same time, the number of attacks also going to increase. So security is paramount for the company that working with these sectors. If you look at Europe, there's a similar trend that the number of the market share will also increase. The number of connected device also increase. And if we look at, I want to mention here, highlight here, is that according to the report by Gartner, that 25% of all cyber attack, again, business will be IoT based in 2025. This is just emphasize on the importance of security for the IoT, for the industrial IoT's infrastructures. So that's all for this part of the presentation. That focus on we focus on the cyber attack and some statistics to show you how important it is, the security when we talk about security for the IoT infrastructures. So now I would like to give the floor back to my colleague Anna, sorry, to provide you a bit the overview of the research activity in Sirris, and maybe interesting for you what they are doing and so on. Thank you.
Thank you, Amanda. We have 2 women in our group and they cannot learn our names. So can you see my slides yes. So I guess you all know Sirris because you probably subscribe to our newsletter. Just a short overview, we are an industry-owned collective research center. For the Belgium industry, we do R&D research for companies, which means that over 70 to 80%, depending on the year, of the companies we support are SMEs. So it makes very interesting research for us. And how we do this, we cover the 3 regions in Belgium, Flanders, Brussels, and the Walloon region. And usually we try to identify, we talk on a daily, hourly basis with companies in workshops like this one to identify what are the collective challenges. And then we either try to tackle them within a big collective research projects or through really bilateral one-on-one personalized projects with companies. And finally, I think one of the most critical things we do is transfer, share, disseminate as much as possible what we learn for the rest of the community. So within, as we said already, we are from the software engineering group. It's been around for 15 years, so the name is a bit maybe a legacy here also. It started with expertise supporting companies, mainly the business models of companies through different software solutions. But we expanded our expertise with research, with actual industrial research on privacy and trusted data analytics, on secure and distributed computing and IoT, and agile security for smart and connected systems. So we do this, as I said, the same as the mission of Sirris, through practical and technical advice, through strategic R&D collaborations, and we have a very broad European network through our European projects. So this helps us learn even more. Specifically, the 3 topics that might be of interest are within the cybersecurity topic. We focus on the system security, the data security, and the data analytics security. Within the system security, we focus on the access and usage control within IoT ecosystems. In this aspect, we also analyze cyber threats analysis and mitigation for these ecosystems. And a critical part is, of course, the secure device onboarding, management and operation. So we do this within several national and international projects. I'll just give 2 examples, one of which is our European IT project Scratch that we have together with Enviso and several other European partners. focusing on integrating security aspects through the whole process from design, development to operations of an IoT system. So your Enviso has been very active within the WASP community thanks to this project, so feel free to follow up on their activities. Another project is Insight Products on actionable insights into product service delivery. There, the main interest of companies was to kind of design a condition monitoring framework for in view of predictive maintenance of their products. But we noticed very early in the stage that once you connect your products, security is paramount. So we also developed at the end a prototype, which was not meant to be, which was not the idea originally, but we developed a prototype to showcase different security aspects for the whole, the hardware, the communication, and also the backend. The second research area on data security, we focus mainly on data sharing, transfer, and storage. Two examples of projects are TICPS and Sunrise, also European projects. Within Sunrise, it's a very cool one. I'm personally involved in this one, so I like it very much. Basically, we work together with our AI group, and we apply machine learning and federated learning in view of intrusion detection on device, but also when you combine information from several devices and you send it to the cloud. Of course, important for this is privacy-enhancing technologies, such as homomorphic encryption, supported by NXP in this project. And we have Dutch partners that are also supporting the manufacturing of uniquely secure low footprint ASICs. So it's a very nice one. And finally, on secure data analytics, with the hype of AI, machine learning renewing itself, federated learning, we saw an opportunity there that, I mean, we see that a lot of AI experts that have been kind of working in the dark, which is also something that we do not advise. When you look for AI expertise, it's also not the last thing you should do. But I've been working on in the dark in the cloud infrastructure. Now we see that with edge computing, the computation, the intelligence is moving more and more to the edge devices, is becoming much more horizontal and distributed. So in that sense, security and privacy becomes paramount. So we are very proud of one of our projects that just started on 3 industrial cases in 3 MAC and shape on sustainability, smart cities, and energy, where we indeed focus on secure access control and security and privacy on edge devices when you try to do something intelligent in these devices, when you either do some lightweight analytics on device or you distribute the computational capabilities between different devices. Then it's of course important that you have control of the data that moves around. And finally, you are still welcome for a project that we just submitted. It's a collective research project, so it's with a large industrial user group on cybersecurity for manufacturing, specifically for SMEs. As I said, these are the companies usually that need our help the most, but of course we work also with large enterprises, and big companies are also welcome. Without a doubt, but there we'll be focusing on cybersecurity maturity models, technical solutions, and practical guidelines to reach cybersecurity targets. We'll also develop a demonstrator, including some simulation of attacks, and of course resulting guidelines. So lots of content to be generated within 3 years. And this is kind of ends my presentation. So I hope we managed to scare you, to showcase you that connectivity opens up a lot of opportunities, but you're already aware that with this also increases your vulnerability and creates quite some security risks. Therefore, our next presentations will be focusing on the security challenges for industrial IoT products, for specifically the product builders and factory owners, and how to tackle the security of industrial IoT products. But before we go to our next speaker, we have some time for questions. If you would have already questions, the floor is yours. Shoot, raise your hand. Or think about them, and we can also still always cover them at the end if you don't dare. But as we said, security is something to talk about. So if nobody dares, then I suggest we go to our next presentation. It's clear, thank you. Thank you, Mathieu. You can also challenge us. You don't need to question, to raise questions. You can always challenge us. So our next speaker is Cedric. He's manager and responsible for IoT and industrial IoT security services at Enviso, which is a cybersecurity consulting firm, and he will talk about security challenges when connecting machines to the cloud. Cedric, the floor is yours.
Thank you, Anna, for the introduction. So I've shared the slides. Let me know if somebody cannot see them. So yeah, hello everyone, also welcome from me to the second presentation of today's awareness workshop. Thank you, Mathieu, for the confirmation. So earlier today, Sirris presented us with a nice overview of cybersecurity in industrial IoT and in the Belgian manufacturing industry. They really showed us what could go wrong. Now, during this session, we will really continue with the key security challenges surrounding the topic of connecting industrial equipment, industrial machines, and so forth to the cloud, the IIoT. So my goal today is to provide you with an overview of what to look out for and how to do this securely. Now, I'm also very happy to have heard during the round table earlier that the audience consists of both factory owners and product builders. So this is nice because the presentation really tries to target both. So I really try to give you a view of the complex ecosystem that surrounds security of industrial IoT. So yeah, I would also like to remind you that please ask questions. You can ask them in the chat during the presentation. I will try to look at them and perhaps I can answer them immediately. If not, we will take some time after to go over them one by one. So I'm going to the next slide now, so let me know if the transition didn't work perfectly. So I'm quickly again going to introduce myself. So as Anna already said, I'm Cedric Bassem. Within Enviso, I'm responsible for our industrial IoT and IoT in general security services. So within this service line, we basically provide support to our customers during both development of connected products as well as the deployment and installation of those products in complex ecosystems. So let me perhaps also quickly provide you with a quick overview of the company I work for, Enviso. So Enviso is a pure play cybersecurity consulting firm. We have our headquarters in Brussels, Belgium. Today we also have in Frankfurt and München in Germany offices, and we are 100 security professionals. Now, what makes Enviso unique is that each of these security professionals really has their own specific area of focus within cybersecurity. And this really allows us as a company to provide our customers with a wide range of services, covering, how we call it, the entire cybersecurity incident lifecycle. And so we can help our customers in defining and delivering a cyber strategy, but then we can also help them prevent incidents from occurring in the first place. I think about trainings, your typical ethical hacking exercises, where we try to identify vulnerabilities in the environment. But we can also help our customers in detecting and responding to cybersecurity incidents. And so both helping set up the monitoring capabilities and validating and verifying whether things go wrong. And if they go wrong, we are there to actually help you along the way and make sure that the incident is well maintained and contained and handled. At the bottom of this slide, you see Enviso Labs, which is the research, so our R&D pillar at Enviso. So we actually invest quite a lot of our time and money, 10% actually, into research and development on a yearly basis. And this allows us to provide you with presentations such as these. This also allows us to keep on top of the ever-changing landscape of IT and IoT. As you know, things move fast in industry and in cybersecurity. What's on today's agenda? So today, I first want to start by discussing the case of connecting machines to the cloud. And so really looking a bit more in depth into the case of industrial IoT. What is it? What is it about? And then quickly moving on towards the challenges. So the idea would really be to discuss the challenges concerning this case. And then I do not only want to tell you what can go wrong, but I also would like to already give you part of the puzzle so that you can already go and start read up on the topic and actually can help and prepare to tackle those challenges as well. So the connected machines case, let's start with that one. So having connected assets means that you will be integrating operational technology with information technology. This industrial IoT really creates, in a way, new communication channels that can connect assets with other sources of live intelligence in your environment. And as Ananda already shown in the previous presentation, the advantages of that are very clear. It can enable new ways to increase your operational efficiency. It can help you reduce downtime. You can do predictive maintenance, 24/7 monitoring and remote assistance of your machines. You know, really the list goes on and on. But when done in an insecure way, this can really leave your OT environment vulnerable with all of the potential consequences. Now, before diving into how to secure this, let's first look at what the general security concerns are, and let's take it from there. So the general setup might actually get very complicated, but in essence, you often will have your connected asset, your machine, that will be connected to a supporting cloud infrastructure, which then allows for some operational management. So on the end use, of course, is to be able to aggregate data, do some analysis on the data that will allow you to optimize operations. It will also allow you to do predictive maintenance, to remotely control these machines and so forth. Now, the machine itself can come in different flavors. You can, for example, have a machine that is already connected the moment that you buy it, so that already provides those connection capabilities. As we will see later with HMS EON, and they provide solutions, for example, products that you can attach to other industrial components that are not yet connected, not yet smart. So the connected aspect can come from different places. But in essence, you will have a machine that will be connected to a supporting cloud infrastructure. That machine will perhaps already be able to process some data, but it will interact with the cloud. It will send data to the cloud, and it can also receive configuration from the cloud. At the same time, that supporting cloud infrastructure really is there to, as a central connectivity hub, so to speak. So it will be there as a central entity that will manage remote access, that will aggregate data, and that will also provide you with monitoring and alerting capabilities. Again, here the cloud, it's also important to notice is that the cloud itself, it can be, for example, your own cloud that you already have as a factory or facility owner, one that you already have in your company. It can also be that this is a cloud that is provided by the product vendor or the machine builder. So to make things more concrete, what are we talking here about? So here I take the example of the HMS EON. And so the HMS EON really is an industrial router device that on one hand, it can talk industrial communication protocols, so you can make it integrate and connect with machines on your factory floor. And then on the other hand, it talks IT protocols and it can connect with the Talk2M, the cloud infrastructure of HMS E1. And through this cloud infrastructure, it really allows for remote access and maintenance and aggregation of data of those HMS E1 devices, but also then the devices that are connected to those. So if we look at the challenges concerning this setup with regard to security, a common misconception that we hear quite often is actually that the security of this entire setup would be the sole responsibility of the machine builder or the product manufacturer. Now, actually, it's quite more complex than you might think. There are actually many parties involved before the product is created and installed and operational within an environment. And actually, during every step, as we will see in that process, there are quite a few security challenges to be tackled. And so in general, for the machine builder or the product developer, these challenges will be mostly around making sure that the product that you develop is securely developed and that you can really support your customers, the factory owners, in making sure that your product is installed and used in a secure way. The factory owner, on the other hand, for them, it's all about this IT-OT convergence. You will have all of a sudden, oh, there is an echo. Everybody can mute. Okay, thank you. So for the factory owner, it will really be all about this IT-OT convergence. So all of a sudden, you have your OT environment where you're now going to introduce IT equipment to this IT equipment. It will communicate to the outside world. So all of a sudden, your OT environment is no longer fully segregated from the outside world. So this means that you will really have to think about secure installation of those products within your environment and about the day-to-day operations to make sure that everything remains secure. So let's start with looking at the product development process. So here we are really looking at security challenges for the machine builders or the product developers. So the main challenge here, of course, is to avoid coming into the news with your product being hacked. This, of course, is bad reputational damage, something that you really do not want as a product developer. I took here an example that I found on Google after a couple of minutes of searching. So it's an example from Forbes article from January 15, 2019, which has hackers take control of giant construction cranes. And so in the context of operational technology and so forth, I think this makes a lot of sense. You have a construction site where you have a crane that's there to build things. If that crane is hacked, it will not only cause operational downtime, it will not only cause the building of whatever it is that you're constructing on that site to come to a halt and to stop. But it might also cause harm. It can also have safety aspects related to it. Imagine that an attacker can drop the cargo that crane is pulling from the ground and it falls on somebody. Can be casualties, can be damages. Really, all of those things are things that you really do not want. So in general, how should a product developer or the machine builder go about securing their product? Well, roughly put, they really have to think about introducing security in every step of the product development lifecycle. And this means thinking about security during design, development, and testing, but also during adoption and the decommissioning of those devices. The design one is actually a very interesting one to talk about, because if you think about operational technologies and then connecting these to the internet, it really makes the design that much more difficult, because if I would have an IP camera, it might be pretty straightforward what to think about. But if I'm going to introduce or connect cranes to the internet, all of a sudden there are some very real challenges that the product developer has to think about. Where are those cranes going to be deployed? Will those cranes have constant internet access? What about if we find security vulnerabilities in our product? How will we be able to make sure that those cranes are patched securely in a timely manner? How will we be able to make sure that that product, it's not a product that's going to be there for 1 or 2 years. No, it's probably going to be there for decades. how can we make sure that our products remain secure over all this period of time in all of those harsh environments where it's going to be deployed? So these are some real things to think about before actually starting the development, because it will have a big impact on how your product is going to look and how your product is actually going to be secured. Of course, during the development itself, we'll have to think about how to securely develop that product. You will have to think secure development processes, education of your developers. And then once you have a developed process during testing, it's important to also validate the overall security posture of your product. Now, the story doesn't end there. Of course, that product is going to be deployed somewhere at your customers. So it's really important as well to think about how it's going to be adopted. How is this product going to be introduced within an operational environment? What guidelines should I provide my customers so that they can, in a secure way, install those products in their premises? How can I provide them guidelines with, once that product is going to be decommissioned or removed from their environment, that my customers can rest assured that there are no secrets stored on that device that, when falling into the wrong hands, can cause harm to my customers. And so these are also things that the product developer should think about during the design of their product. As you can see, there are quite a few things to think about, and it can get quite complex. So perhaps it makes sense as well to highlight the importance of security standards and certification within the product development landscape. So there is a lot to say about this topic, and I can really talk for hours concerning this. There are many different standards and certification schemes out there, but let me just quickly provide you with a couple of them that I find that are very important and also very relevant to the use case of connecting machines. The first one is a standard provided by OWASP. It's the OWASP Internet of Things Security Verification Standard. It's also a standard that we at Enviso actually co-led the development of during one of our R&D initiatives. And OWASP, it's an open source community that takes it upon themselves to really create guidelines and requirements for all types of applications. So they have secure development guidelines and requirements for mobile applications, web applications, development life cycles. And now they also have a guide, the ISVS, to secure or to have the security requirements for connected products that are part of a large and complex ecosystem. Why is this interesting for this presentation? Well, for the product developer, this guideline can serve as a basis during design and to make sure that you check off the right requirements for your product. And at the same time, guides such as these can also be used by the factory owners in their decision to choose a right product. There are multiple standards out there, but you can always request to have a certain assurance whether or not a product is secure. So you can ask product developers to have security assessments performed on their products. And if the security assessments are performed by standards that are well known and well used, such as the OWASP ones, this also allows you to really go and compare the quality with regards to security of different products. Another certification that you will often see being used and placed on company websites is the ISO 27001. It's really a certification on an organizational level. What does this certification scheme mean? When a company is ISO 27001 certified, it really means that the company takes security at heart. It really means that the company has management commitment for making sure that their company and the products that they create go through a process where security is taken up at the basis of it, and that security, the overall level of security of those products and services is really increased on a case-by-case basis, so that there is a continuous improvement on that regard. So this can also provide you as a factory owner some reassurance that that company takes security seriously. And then it's also important to not ignore the ICS aspects of this story, the fact that we are talking about machines in operational technologies. And here as well, there are some standards and guidelines out there that you can rely on. I think the most well-known one in that regard is the IEC 62443. It's a Security for Industrial Automation and Control Systems guideline. With regards to product security, there are two parts of this guideline which are very relevant. It's part 4.1 and part 4.2. Part 4.1 really discusses the secure product development lifecycle requirements. So it really discusses how you can make sure as an organization that your development lifecycle for your product is secure. On the other hand, you also have the part 4.2, which really provides security requirements, technical security requirements for those industrial automation and control system components. Okay, so having the installation part, the development part of the product covered, we can move to the installation. So at some point, you will have a product that is ready. That product will have to be installed somewhere at an environment by a factory owner. There are quite some security challenges here as well. So in general, you can say that here the main challenge for the factory owner is really what we would refer to as this IT-OT convergence. So historically, you have your OT environment, which consists of all of your ICS, your machines, your PLCs, your SCADA equipment, and so forth. Historically, this is an environment which is well segregated from other environments. It works on its own, and it has its own processes and services and people that look at it completely separate from the IT environment in your company. In that IT environment, you will have cloud infrastructure, offices, all of those IT servers that you would expect there. And now with the introduction of connecting these machines to the cloud, you really create this overlap and this IT-OT convergence, which is often dubbed with industrial Internet of Things. And this brings a certain amount of challenges with it, because it means that now the security concerns of this IT world will also become very relevant for this OT world. And there is this overlap. So you actually increase the attack surface in a way of both environments, something that you would like to avoid, of course. And on top of that, so this means that if something in your IT environment would get compromised, it might propagate to your OT environment and also cause operational downtime. It would mean that if done insecurely, it might be very difficult to contain certain security incidents from spreading. Next to this technological aspect, there is also the aspect of people, of course, because the people that every year are now familiar with how this OT environment works, and then you have the people of the IT environment, and well, yeah, they have to learn from each other on how to make sure that this convergence is done in a secure way. So there are quite a few things to take into account here that prior were not there. So if you think about it, during the installation, there are two very important parts where you have to take note of. So of course, there's always the choosing of the right product, but once you have a product chosen, then it comes down to making sure that that product is installed correctly within your premises and that it's also configured correctly. So what do we mean with secure placement of the product? So here we really look at, you want to place that product in such a way in your network architecture, in such a way that compromise of those IT equipments will not compromise your OT environment. And so if you would have a connected machine, for example, let's say a connected crane, you would configure it in such a way that compromise of that crane will not compromise your entire OT environment. You want to install it in such a way that it's in a dedicated zone, segregated from different segments and other zones in your environment by proper firewall rules and switch configurations. And you also want to have it in such a way that all communication externally really goes through that hardened and secured cloud environment. I really want to avoid that somebody from the internet can directly create a communication with your OT environment and start compromise from there. If you would look at configuration, here it's important to consider both configuration standards that are prominent in the IT world as well as those in the OT world. There are a lot out there, but I think one of the easily accessible ones and that are very straightforward and easy to implement are the ones provided by the Center of Internet Security, the CIS guidelines, so to speak. These are really target the IT world of things. So here you have CIS controls, which really provide guidelines on how you can manage your IT assets within your company. And how you can make that manageable, and we can implement monitoring and so forth on those parts. Then on the other hand, you also have the SIS benchmarks. What's interesting here is that they provide very tangible and very concrete configuration guidelines for systems and cloud infrastructures. So here you will find guidelines for Linux, Ubuntu servers, for example, on how you can securely configure those Windows machines, but also for cloud environments. So Microsoft, Azure, AWS, and so forth. They provide very concrete examples, very concrete configurations that you can apply to these systems to make sure that certain baselines are maintained. They provide different levels so that you can go from baseline to more advanced security as well. Of course, on one hand, you have this IT world, on the other one, you have this OT world, so it's also important to consider the standards and guidelines that you can find for that part. Here again, I will refer to the IEC 62443 controls, but now more everything concerning part 3 of that framework. Here you will really find very concrete guidelines on how you can configure your OT systems and how you can correctly and securely integrate these in your entire environment and ecosystem. And then, of course, not to forget that you buy a product from a product vendor. And as we started, as I stated earlier, it's also the responsibility of that product vendor to assist you in that installation. And so there, they can also provide you with secure guidelines on how you can securely install those products in your premises. I'm thinking here about the correct placement in the network, for example, what you can and can't do, what would be regarded by them as a correct use of your product. I can also think about, for example, removing insecure configurations, insecure defaults. For example, perhaps during installations, there are default credentials that have to be changed on that machine. These are all things that your product manufacturer can specify in guidelines on how you can securely configure those products and securely use them. Of course, once that product is installed in your premises, the story does not end there. Once it's installed, it's going to be there for a couple of decades. So this really means that you really will have to think as well about the day-to-day operation of those products. Of course, having one crane, one connected crane, perhaps will be very easy to manage, but what about 1,000? What about 2,000? Might make things a bit more difficult. So the more machines you connect, the more difficult it will become to maintain that oversight. Now, in the IT world, tools exist for a very long time on how you can actually go and monitor communication channels and to use those monitoring tools to really go and detect whether incidents are occurring, whether certain malicious behavior is being observed in those environments. I think what's important for you to know here as well is that tools such as those also today exist for OT environments and where they really combine the best of both worlds. And so they really differentiate themselves from those IT tools in that they will not only look at IT communication channels, but they also know about all of those industrial control protocols, so that they will also know, for example, if certain, so you as a user of those tools will also be able to configure certain values that should not be exceeded. And for example, you could say that the temperature of a kettle cannot exceed a certain value. Well, here these are things that you can configure in these tools, and they can try to identify whether certain malicious behavior is occurring that tries to change these values in those operational technologies that are in your environment. Of course, having the technologies is one thing. Actually knowing what to do in case an incident occurs is an entire different matter. And so here we're also really looking at, you have to make sure that you have an incident response plan ready, that you know in your organization what to do in case something goes wrong, who to talk to, who has which responsibility. So really that you are ready in case that an incident occurs. Also communication to the outside world, all very important things to do. Know that here as well, you can get help from third parties and that can help you set up these things in your organization. And that can also challenge you and during, for example, war games, where you can actually challenge your management and see whether they take the right decisions in case a certain scenario would evolve. And finally here, it's also important to realize that in the end, people will be using those systems. It's important to use or pay proper attention to everything concerning awareness and proper use and training of those systems. And yeah, it's also very important to realize that security or nothing is secure forever. So even if you can have a secure installation at day zero, things change towards time. So it's important to continuously validate that your setup is still secure, to continuously challenge whether you have today is still secure tomorrow. And so really realize that this is something that you'll have to work on a continuous basis. So wrapping up, I think we can conclude that security, when connecting machines to the cloud, is really a shared responsibility that spans over different steps in the deployment of those machines in an environment. So during product development here, the product developer itself is really going to look to guarantee that they do secure development, that the end result of the product is secure, but that it also remains secure, so that they realize that security vulnerabilities will be found in the future and that they have a contingency plan ready to make sure that their vendors are informed in case, or that their customers are informed in case vulnerabilities are identified, and that there is enough support for their customers to help them in securely placing and installing those products in their premises. During installation, it's all for the factory builder to make the factory owner to make sure that the product is securely configured and that it's securely installed in the network, and that blend between IT and OT components is well maintained, and also that there is a good validation that everything is correctly placed in that environment. And then, of course, the day-to-day operation is all about monitoring, detecting, and responding of cybersecurity incidents, making sure that your users are security aware and that you realize that something that's secure today might not be secure tomorrow, so that you invest in repeated validations and making sure that you maintain and keep on increasing your overall security posture. So this concludes my part of the presentation. And so in the next presentation, I'm going to give the word to Jean-David from HMS Industrial Networks SA. And they are really going to give you a very concrete example on the lessons that they learned on securing their product. So where we looked at the general concerns and the general challenges, they're really going to show you how they tackle those on a day-to-day basis. I'd like to thank you for your attention. In case there are any questions, I would be more than happy to answer those. Thank you.
Thank you, Cedric. I see we have quite some time for questions. The floor is yours.
Yes, I have a question about monitoring tools, because you said, okay, there's tools out there that are not only able to monitor your IT infrastructure, but also your the new infrastructure, the IoT infrastructure. But in what sense are the IoT devices different? Because in a way, they're all typically small computers themselves. Can you expand on that a bit more, please?
Yes, for sure. So you can actually perform monitoring on different levels. And so in a way, indeed, and if you would take the example of, for example, a simple sensor device that would send data to the cloud, the monitoring part, you could say, okay, let's limit that one to the communication to the cloud, for example. In the cloud itself, you can also do certain monitoring of how things are happening. So there, indeed, there is not that much different. But you could also, for example, say, let's go a step further and also provide or implement monitoring in that OT environment, and where the communication between that sensor and the OT environment takes place. There you could also install tools that are developed specifically for those OT environments, and that actually knows about all of those industrial protocols, and that can learn from the communication that occurs there. And on that level, that might be another source, monitoring another source of information that you can use to actually go and detect incidents from occurring. So there I'm thinking, for example, at tools that would monitor whether there are certain updates that occur or changes, configuration pushes to certain PLC systems. And these are things that you could configure in these tools in such a way that you say, okay, I do not expect these to happen, so if they happen, raise an alert. I'm not sure if this answers your question.
Yes, yes, I think so. Although I would say you could do that monitoring regardless, but I think what you're saying is the reason to do that is now there's more reasons to do that now because you have created a path from the outside world to your inside infrastructure, right?
Exactly. Yeah. Indeed. Because there is now this path, and this opens up your OT environment, and this makes it important for you to pay extra attention to the new threats that are then the new risks, more better to say, and the new risks that now can affect that environment as well.
Yeah.
I think an example of such a tool that I will be referring to is for example, Nozomi, which is they have such an appliance where that monitoring can be performed. Another one would be the Tenable IoT one. It's also something that that you might look into.
Yeah, thanks.
I also have a question. It's Bram Verden speaking. Cedric, and during your presentation, you touched upon the integration of industrial machines or components within your network. Is there guidance out there on things on I don't know, minimal requirements or absolutely must-dos when you're integrating a new component in your network, or things that you should absolutely not do? Is this somewhere documented, or do you have some reference on that?
Yeah, so to a certain extent, the IEX 62443 will be your guide on that one. Though I must admit that it's not an easy guide to start using. It's a very big document with many requirements spread out over multiple hundreds of pages. Really like a guide really concerning the placement of your products that's not too convoluted and very easy to read. I'm not familiar with one that is ready there to be used. It all really boils down to following the general principles of network segregation. So it's really all about making sure that the location where you place that device in your network and that it's well segregated from other environments. And basically during that entire process, you really have to ask yourself the question, what if this component is compromised? From that place, where can then the attacker pivot to other places in the network? And that's what you will have to really close down during that part. So it's really about, imagine that you have a sensor connected to a machine in your OT environment that connects to the cloud. You would say, okay, if that sensor is compromised, does that mean that the attacker will be able to reach every device in my OT environment? Well, hopefully not. So there you will want to make sure that firewall rules are configured as such, and that only those devices that it's connected to are compromised, or only a subset of devices is compromised. And depending on what's manageable, because it will always be a sort of, how would I say, balance between how much segregation do I want to include and how much segregation is actually manageable, say on a crane by crane basis, but that might just be too much to manage.
Okay, so here it's also actually applying some IT principles, IT security principles like segregation, which can also be applied in an operational environment.
Yes, indeed.
Okay. Okay, thanks.
Yeah.
Any other questions from the audience? We have 3 minutes. Otherwise, you can also keep them till the end or send them offline. Thank you, Cedric, for your presentation. As usual, very nice one. Thank you.
Thank you very much. With pleasure. As Anna said, don't hesitate to reach out in case you have questions. You can reach me on my email address, sebastian@viso.eu. Thank you.
Thank you. So our next speaker, I think maybe even the most important one here, it's the practical solution to our lessons learned. Jean de Wiet, he's Information Security and Technology Manager at HMS Industrial Network. which is one of the leading independent manufacturers of products for industrial communication. And he will focus on lessons learned on securing their products. Jean-David, the floor is yours.
So we have discovered with Sirris the global picture of IoT in the world and specifically in Belgium. We have seen with Cedric and Enviso the best practices in terms of IoT implementation. We will deep dive now in the practical development of an industrial IoT product. I'm Jean-David Epaya. I've worked 20 years in IT and security departments, mainly in international banks, and I've moved to the industrial sector in 2019. I'm the IS and IT manager at HMS Industrial Network in the business unit E1. I remember that when I began to work in 2000, IT security wasn't doing the newspaper headlines, and doing online shopping in HTTP mode wasn't a problem for many people. Fortunately, things have changed now, and the retail internet and information technology have matured a lot. Let's see how not to repeat the same mistake with the operational technology that we were doing 20 years ago with IT. So what is HMS? HMS stands for Hardware Meets Software. It's a listed company in Sweden. At HMS, we create product enabling industrial equipment to communicate and share information. HMS vision is to become the world's biggest industrial, and I insist on the word industrial, we are not Microsoft, so the world's biggest industrial information and communication technology company. So to succeed in this ambitious vision, we are 700 skilled and passionate professionals in 16 countries in the world, and we develop, we manufacture, and we sell products. In Belgium, we are around 60%. So HMS playing field is industrial ICT, and we segment our playing field in 3 areas, which are control-centric application, information-centric application, and communication infrastructure. And you can see on this slide some example of typical industrial application for HMS solution, like energy management or wind turbines. In the following slide, we will talk only about the first orb at the top of the slide, which is industrial matching and systems. As I said, I'm working in the business unit E1. So what is E1 for HMS? E1 is the Belgian brand of HMS. And we focus at E1 on remote access and data for PLC-based matching. This is our business. We produced our first industrial internet gateway in 2001. And so we are celebrating 20 years this year. At this moment, there are more than 300,000 devices, 300,000 machines, in fact, connected in the world thanks to our solution. I've had the look this morning, it was 310,000. What do? We build industrial gateway called COSI and Flexi, which connect to all major PLC. These gateways are also connected to our cloud called Talk2M, and our solution allows 3 things: the remote access, the monitoring, and the data collection from anywhere in the world. Remote access or remote assistance is the fact to connect to a machine at the customer side, to get live with the PLC, and to work as if you were there. It allows to support the field technician during the commissioning, but also to provide assistance during the life of the machine. We also allow to monitor the PKI of all machines in one place, and we make data available to software for analysis and production optimization. Typically, our customers are machine builders, solution integrators, and factory owners. This being said, how does it work? Today, we will focus only on remote access. Remote access is typically wanted by machine builders. So what's the typical need for a machine builder? He builds a machine and sells it to a factory owner. And he wants to be able to perform remote assistance on it while minimizing travel cost and proposing a short assistance SLA. So to do so, on the machine side, inside the factory plant, he plugs an E1 router to the heart of the machine, the PLC. The E1 device makes an outgoing VPN connection to Talk2M. Talk2M is a rendezvous cloud made of dozens of servers around the world. And the user on his side has a special software installed on his PC, establishing a secure VPN connection between the PC and Talk2M. So communication is made by the VPN tunnel linking both sides. Of course, both sides of the communication need to access the internet and reach the Talk2M server. Therefore, the machine builder must convince the factory owner to have this device performing remote connection through the factory network. The factory owner, or as we see more and more, the IT manager, will take the final decision for implementation. The job of the IT manager is to take all necessary measures to protect its infrastructure and network. So he needs answer to its security concern to take his decision. And he needs to be sure that the devices in his factory floor linking the machine and internet are secure. So we at E1, as product developer, we are responsible for providing such secure device. So on the schema, you also see you have the computer, but we also have a phone version of the application and a web application also. But we will mainly talk about the computer one. Before developing a secure product, we need to wonder what are the risks to which our product will be exposed. The establishment of a risk assessment before the development of the object is a critical step if we want to ensure security by design. Even macroscopic, this analysis will identify the risk applied to the object and the legal, financial, human impact in case of an issue. Classically, risks are measured by the multiplication between three factors: a threat score, a vulnerability score, and an impact score. What is a threat? A threat is a negative event. What is a vulnerability? Vulnerability is a weakness in the system that can be exploited by a threat. And an impact is a consequence in case of loss of confidentiality, integrity, or availability. And an impact can be financial, legal, reputational, human, whatever. So first of all, we must have a picture of the threat surrounding the connected device. Practically on the field, what are those threats? So we see our connected device in the center and around some threat. First of all, we have the malware, or the penetration of malicious software performing unwanted and unauthorized action. Ransomware, viruses, Trojan horse, spyware are common examples of this threat. We have the denial of service. They can be bidirectional. It can target an IIoT system itself, resulting in production disruption caused by a massive number of requests sent to the system. On the other hand, an attacker may take advantage of a large number of compromised IIoT devices and create an army of botnets attacking other systems. We also have the manipulation of hardware and software. In terms of industrial IoT system, an attacker could manipulate an industrial robot or modify its configuration. We have the man in the middle. This is the threat where messages exchanged are intercepted by an attacker. The attacker may just listen, but he can also modify or delete transmitted information. We have the information loss or manipulation, the leakage of data, including personal data. It could be your research and development secret or some personal data leaking on internet, leading to legal issues. You have the outages, the loss of support services or the third-party failure. You have the improper user management. This is typically user having right to see information or to modify information they shouldn't see or modify. And finally, another threat is the user mistake that can be intentional, but also unintentional. So I said that threat exploit vulnerabilities. Now that we know the threat, we can begin to work on a product without the vulnerabilities exploitable by this threat. By the way, we just mentioned some potential threat on a connected device, but security is a chain as strong as the weakest link. So to have a full overview of security, we should talk, in addition of devices themselves, of threat in the cloud solution, threat in the end user application. But today we are limited by time, and I've just focused on the device. But again, normally the risk analysis must be repeated on every component of your connected chain. So we made a threat analysis of a connected device, but in our case, it's not sufficient. Why? Because we are working on PLC-based matching. We are doing industrial IoT, and IIoT has some additional constraints on top of IoT challenges. So we must also perform an analysis of the device in its environment. Here in the table, I've listed some classical aspects of a connected component and their differences if it's an IoT or an IIoT object. So first of all, why an individual buy a smart object? It is usually because it will bring him easiness on an aspect of his life. Example, the smartphone versus the landline. Why a machine builder on his side wants his machine connected? To prevent failure or to fix a failure. So IIoT object, in this case, must have a high degree of resilience. If we speak about failure, if your home camera is not working perfectly, you will contact the support, you will send them a tweet. But if a water treatment factory stops or does not properly sanitize the water, the impact will make news headline. So the IIoT object must be highly available and trusted. In terms of patch management now, if your ebook reader asks for an update when you switch it on, you will have to wait 2 minutes, no problem. If a device is vital to a factory line, its update can be delayed until the next maintenance window, and it can occur in several months. So security in an IIoT object must be layered to still ensure the global security if one of the layers falls. Finally, in terms of life cycle, renewal frequency of a phone, for instance, in retail, is 3-4 years. Some connected devices can even last less than a year. On the opposite, industrial machines have a lifespan of 15-20 years. Security must be then renewable during the lifetime of the object. And finally, in terms of reachability, your connected smartwatch can be considered as relatively protected against an attack that needs a physical access. I hope that you realize if somebody tries to plug an USB in your wrist. But we cannot say the same of a connected wind turbine in the middle of a field. Therefore, a connected device must ensure its own security. All the specificities of OT weren't a problem when OT wasn't connected because the industrial and the IT timeline were completely uncorrelated. Now that IT and OT are linked, scenarios that were before only applicable to IT are now applicable to OT. It can be summarized in a small word game with IIoT. We all know that IIoT means Industrial Internet of Things. But in fact, IIoT could also mean Industrial Internet meets operational technology. IIoT is already everywhere, connecting devices in the banking industry, in smart city, in smart health, traffic, logistics, even in smart farming. But we at E1, we specialize in connecting PLC-based machines. So what are the conclusions of our analysis? What must be the security characteristic of an industrial IoT device connected to a PLC-based machine? What are the challenges for a product developer? The challenge on our side is to provide a fully secure solution from edge to cloud to final user. For us, the security foundation is built on 4 pillars. Insurance of object identity, insurance of confidentiality of data entrusted to this object, insurance of integrity of the firmware installed on the device, and the maximization of availability. We recognize the well-known triad confidentiality, integrity, and availability with the addition of identity. Why do we add specifically identity? Because in a world with billions of connected objects, knowing for sure with whom you communicate is crucial. So say differently, identity is authentication, confidentiality is encryption, and integrity is code signing. I don't know your level of knowledge in this domain, but authentication, encryption, and signature is a description of asymmetric cryptography. So just remember that in an asymmetric cryptography, with a pair of keys, a public made public and a private kept absolutely secret, you can ensure confidentiality, identity, and integrity. Asymmetric cryptography is incredibly secure when well implemented. And of course, when the private keys are kept secure, absolutely secure. So challenge number one, how to keep those private keys secure in a device that is potentially not supervised. So in our opinion, the only way to do so for the next 10 years is to implement security in hardware. Why? Because remote assistance done with a software installed on the computer plugged to a machine is perfect if you are the computer nerd in the family who has to keep your parents' computer up to date. It is easy to use, but it is a potential nightmare, specifically because of how much access it has to the underlying computer. Dedicated device with security in software is much better, but is reaching its limits in terms of security capability. To prepare the next 10 years, it needs to evolve to security in hardware. So with this in mind, protecting confidentiality, integrity, and availability and identity, our research and development department was able to develop the needed requirement for a new device that we call the COSI+. COSI+ is a gateway allowing remote access on which allowing remote access, but on which security has been implemented in hardware. It's very important. Now security is in hardware. I will now explain you the different challenges that we had to overcome while developing the COSI+. In the following slide, I split those challenges in 3 categories: internal challenges, challenges brought by our customers, and challenges brought by external adversaries. Let's go. Remember, the first challenge is to keep secret, well, actually secret, on an IoT device. It begins with the implementation of a super safe electronic component in the heart of the device to store the secret. It's called hardware root of trust. It's a dedicated chip called, in our case, it's a secure element, which only purpose is secure storage and cryptographic operation. It's a non-tamperable chip. So we now have a secure place to put our secret. With this in place, we can be sure of confidentiality and integrity of the secret at all times on the device. So we can now proceed to the next step. With the hardware root of trust in place, we are able to implement security not only between devices, but at the electronic component level in the device. It means that communication are even encrypted and signed between the electronic components of the device. This secure communication between components, you can build on it and you can implement a secure boot. It means that from the moment the device is powered on till the software is loaded, every component and line of code is checked for authenticity. If a step fails, the device will not boot. So with secure boot, we have now the insurance that the software on the device is legit. Why is it important to have digitally signed updates? Because executable and script can cause potential damage to a device. Therefore, it's important that devices verify the authenticity of any new software or firmware prior to their installation or execution. So signing firmware and software update are a critical best practice to ensure that the software installed in your device is genuine. We are still in the chapter of internal challenges. In the previous slide, we build the confidence in the device. But this device has to communicate with the cloud. And this communication must be secure, of course. First of all, our cloud needs to be sure to communicate with a legit device. The way to do this is by providing the device with a birth certificate. The birth certificate is built with some unique identifying element of the device. It is signed by one to ensure authenticity, and it is stored in the secure element, the super safe element of the device, to prevent tampering, so it cannot be modified. Each time that the device will communicate with the cloud, it will present its birth certificate to authenticate itself. If the cloud recognizes the certificate, the device is authorized to communicate with the cloud. If the device is counterfeited, it will be banned from the cloud. The device is connected to a cloud, its communication must be secure. So the product developer must ensure that the latest encryption technology are used and that vulnerabilities are monitored to be patched. Product developer must also be transparent on the security. By implementing open source technology, a worldwide community of security professionals are monitoring the potential vulnerabilities. So it's no security by obfuscation. Security by obfuscation is not security. If vulnerabilities are discovered, patches must be proposed to the customer. The problem we face sometimes is that some customers have heavy validation process for specific firmware, and they don't want to upgrade to a new version, or they need to enter into a new validation cycle that can take time. It leads sometimes to very old version of firmware wanting to connect to the cloud. And it could oblige us, in fact, to ban them from connecting to the cloud to ensure the security of the user. So E1 has chosen to split the update in two tracks, one security track and one new functionality tracks. It allows our customers that don't want the new functionality to still have an updated product in terms of security. So we have seen that secrets on the device are secure. We have seen that communication between devices on the cloud are secure, but how are these secrets kept at E1? It would be useless if our devices were securely storing some information that would be freely available to E1 staff. So at E1, the secrets are sealed in electronic vaults, whose function is to store secrets and perform cryptographic operations, like the signature, for instance. But you wouldn't let the key of the kingdom to a single person. You wouldn't let a single person access or modify your most private secrets. So in a vault, the master key opening the safe is divided into unsealed keys, and a minimum number of unsealed keys is required to unseal the vault. The idea behind that is that the keys are distributed to trusted operators, each having only one part of the secret, so that no one can unseal the vault alone. For instance, your master key can be separated into 6, and you define that 4 parts are required to open the vault. So, your keys are safely stored on the device. They are safely stored on your infrastructure. But again, we have to take one step back. How to ensure that the vault itself has been properly configured? How to ensure that secrets have been produced according to the chosen specification? How to ensure that they haven't been made visible during a single second before being locked in the safe? So it's the purpose of a key ceremony. A key ceremony is a session that oversees the modalities of generation and preservation of cryptographic secrets. A key ceremony follows a bulletproof scenario. It has witnesses and is documented. The smallest incident during a key ceremony, something not planned by the scenario, invalidates the whole ceremony that must be restarted. I invite you to search for the keyword key ceremony on YouTube, and you will see, for instance, for the ICANN, how they do the key ceremony. In the key ceremony, secrets are created by the vault, inside the vault, and are never revealed publicly, even to the key master. Nobody knows the secret, in fact. That's the perfect thing. And at E1, all operations concerning the secret related to the COSI Plus are handled through the key ceremonies. Quickly on secure coding, obviously our developer needs to be trained on the latest security technology and their proper implementation. It's what we call secure coding, so it's training. Finally, you can imagine that we need mature process concerning our physical security, network security, access management, vulnerability tracking, change management, and so on and so on. So we are certified ISO 27001 to help us continuously improve on all these matters. So, in order to provide our customer a secure solution, there are dozens of other parameters to take into account. For instance, availability. It's also a component of security. As I said at the beginning, more than 300,000 machines all over the world are connected thanks to our solution. And this figure is continuously growing. So managing a large number of IIoT nodes requires scalable security solution. In addition, customer needs to be aware of what they can expect thanks to SLA. User management is also an important topic on the customer side. A machine maker can have multiple collaborators, not all authorized to access all machines, and a factory owner must be able to authorize a specific builder to access on some specific machine at certain time, not on all machines on his factory floor at all time. Customer must be able to access logs in case of investigation, so they have to exist. And finally, customer must be trained and supported all along their partnership with us. What could be worse than security reduced to zero because of a bad implementation? So we have a strong support service to help the customer to make a proper implementation and support them during the life of the project. Once you think that everything is in place in terms of security, challenge and accept to be challenged. At E1, we need to work with external suppliers, for instance. This is normal in the life of a company. But we need to ensure that they have the same level of security maturity than us. So we question them, we challenge them, we sometimes ask them to improve some processes on their side, and we repeat regularly the process. We also built a partnership with NVISO to closely work with a pure player cybersecurity firm. And we ask them to pen test our devices, our cloud, our infrastructure in Nivelles, but most important, we implement their recommendation. And as I said, we are certified ISO 27001. So ISO 27001 is a framework that helps us to establish, operate, monitor, and continuously improve. This is one of the most important steps in this certification. Continuously improve an information security management system. And to get certified on ISO 27001, there is an external audit every year. So in terms of security, statu quo is not an option. Security is a continuous process. That's the key idea. So we also have, we had internal challenges, but we also have challenges brought by our customer. What evolution do we see in the market, and what are the concerns of our customer? First of all, we clearly see the IT-OT convergence. As I said at the beginning of the presentation, the IT manager is more and more invited to the discussion. He owns the network, and his blanc-seing must be obtained before plugging something in his infrastructure. Customers are more and more informed about security. They have really specific technical questions, security questionnaire that they send us. It can be challenging for us in terms of time to answer, but also because not everything is shareable in terms of security. So in fact, customers are asking a lot of more and more questions about security, but we sometimes don't want to answer because it could compromise our own security. We also see security watch on the product installed. For instance, when a vulnerability is discovered, like last year we had something called Ripple 20, customers contact us to know if our products are impacted. They don't wait for our own communication, they contact us directly. There is also a need for more and more certification on the customer side. It can be challenging for us because certifications are expensive and are also costly in time to obtain and to maintain. It's why we have chosen the ISO one. ISO is the most international one, it's international standard organization. I personally would like as well a European industrial security framework trusted in all countries of EU and recognized by other countries. So in fact, to summarize, we see customers investing more and more in security. They pen test our product. They are vouching process before installing something in their infrastructure. As this process is expensive on their side too, we see them unifying their fleet once a product has been authorized. So for us, all these challenges are positive as they push us to continuously raise the bar in terms of security. We also have an external challenge. We do know that our solution, devices, cloud, and application, is a target for adversary. The more devices we connect, the more attractive we become for them. It's why we continuously have them pen tested by security professionals like NVISO. We also have in place a responsible disclosure program when white hat hackers want to contact us. So we have some researcher, external pen tester informing us of potential vulnerability on our product. And we discuss with them and we take an action plan before communicating and we solve the issue. We don't offer a financial compensation for vulnerability, but we publicly recognize their finding on our website. And we know that an incident can occur. So we try to be prepared and we have the maximum of tools and process in place in case of a crisis management. So if we quickly draw the remote assistance solution from the machine to the user, and if we add the different security layers presented to you today, we realize that security is a chain. Each element needs the other to be fully efficient. So at the end, who is responsible for security? Is it the device manufacturer's responsibility to solve the security requirement in a factory? The quick answer is no. It's not the device maker's sole responsibility to bring security. According to me, security is a responsibility shared by the product developer, us, but also the machine builder, the factory owner, and all other actors like the supplier, the cybersecurity consultant, and so on and so on. Everyone has his part. But we, as a product developer, we have no control over the specific security policies within a factory or in the middle of a field. Therefore, strengthening the device to handle any situation allows us to provide security whatever the installation condition. As we don't control the installation condition, we provide a super safe product. So our goal is to provide a bulletproof product, coping with all the threats that we've seen at the beginning of the presentation, and have a happy and secure customer. So that's all for me. I hope that you have a question and that I will have answer for you. Thank you.
Yes. So I think I'll be kicking an open door. I think it was clear from our presentation, the kingdom of connectivity comes at the risk. So security should please, and I think most of you here already know, take security into account already from the beginning of your development process. It's paramount for your product. It is just as important as any other business services or operational efficiency that you want to achieve. Especially if you're working with external partners, and you always are, it's a shared responsibility, as Jean-David said, so it is through the whole value chain of your product. In addition, we wanted to highlight a few activities that Sirris and Agoria can provide support in cooperation with also industrial partners. So we offer all kinds of activities in terms of collective initiatives such as workshops, masterclasses, and orienting advice, such as, for example, security scans for your company. So feel free to contact us. It's been on the news quite a while. In terms of dissemination, so we will be having this year quite some activities on cybersecurity, specifically for digital service and product builders, for manufacturing, and for others. And so there will be 3 experts workshops where you can talk to all the experts. There will be thematic events, master classes, so a full program this year. And hopefully at some point we can all also see each other face to face, because it helps the discussion. In addition, this is unfortunately only for Flanders, but it might be interesting. Vlaio is also offering a cybersecurity verbetertrajecten, where you can receive support from Vlaio when you need advice from guidance and advice from security experts. You do need to work, it's a mandatory, so Vlaio in cooperation with also several research institutions, the Federation has selected 9 service providers for this. So it's kind of a certified 9 to provide this advice, of which, as you can see, NVISO is there. So always interesting to take a look for Flemish companies. Of course, within Sirris, we follow up also activities on Brussels and Wallonia level. So if you have questions, we can figure it out for you. And that ends with our presentation. I don't want to take too much of your time. This is a feedback opportunity. So we just wanted to see what was your interest in this workshop. Is there a topic that maybe we did not spend enough time talking about, or would you like a follow-up workshop on a very specific different topic? Just now is your time to shout. Yeah, if you're interested in a separate one-on-one with one of us or all of us, just let us know. So it's not lunch yet. If somebody has any comments, now is the time. Very good presentation, thank you. Thank you, Patrick. If there are no other comments, I suggest we can end earlier, so hooray. Send us a mail. I guess these virtual events, we are all fed up with not being able to talk face-to-face to people, so we don't make an effort sometimes, but send us a mail, let us know. We have very capable experts around the table and very nice presentations, and I really want to thank Ananda and Cedric and Jean-David for this opportunity to work together. It was very nice. And I guess we can have an early end. Thank you. Bye-bye.
Thank you, everyone.
Thank you. Bye.
Bye.
Bye. Bye. Nice.
Bye.
We're going